Hi, my name is John again. Welcome to the law of cosines. The law of cosines is a pretty difficult formula to memorize at first. I'm going to try to give you an easy way to memorize it. C squared is equal to A squared plus B squared minus 2AB cosine of angle C. There's your formula right there. I know it's a really complicated formula, so I'm going to have you memorize it this way. C squared equals A squared plus B squared. This is the Pythagorean theorem. Everybody knows this. And then just go minus 2 times A times B cosine of the angle C. Okay? So conversely, if I go A squared equals, and then it would be B squared plus C squared minus 2BC cosine of angle A. I've got the BC right there. And of course, B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of angle B right there, that B, big B. Well, obviously, if you use the law of sines, it's a lot easier because it's the ratio of the sine of the angle, sine of A over the opposite side A equals the sine of the angle B over the opposite side called little b. So the law of sines is a preferred problem to use. But in certain situations, the law of sines will not be used or cannot be used. And such cases are the SAS situation and the SSS situation. If you have three sides, the law of sines, you don't have one of the angles or both of the angles, so it's very difficult. In fact, you cannot use the law of sines anymore. You have to use the law of cosines. If you have the SAS case as well, side angle side, you cannot use the law of sines as well because you don't have this angle, you don't have this side, the opposite it. So the SAS and the SSS situation is probably the only situations where you will use the law of sines. So where does the law of cosines come from? Well, I'm going to do part of the proof for you. It's in the book. Most of it is pretty simple. And if I label this A, B, and C, and I go straight down like this, and let's call this X right here. And this is going to be X minus C, of course. And I'm going to highlight a certain portion of it, which is located right over here. Of course, as I said before, the law of cosine comes from the Pythagorean theorem. So A squared is equal to, let's call this height H right there. H squared plus X minus C, or excuse me, that should have been C minus X. C minus X 20 squared. And you have to distribute this out, and then you have to find out what that angle theta is accordingly. And so that's gave you about 1/3 of the proof. So let's get started with one of the examples here. Let's put it aside here. Let's go over example number 1. Example number 1 says it's triangle ABC. A is equal to 60 degrees. Little b is equal to 20 inches, and little c is equal to 30 inches. It says find the missing parts. So we're looking for little a, big B, and then big C. So I'm going to try to draw the triangle out. Always try to draw it out. It helps you to actually visualize things. Angle A, little a, big B, little b, and big C, little c. Big A is 60 degrees, little b is 20, and little c is 30 inches. You notice that we have a SAS situation. Since we have a side angle side situation, we cannot use the law of sines. We have to use the law of cosines. Here it is right here. So, little a squared is equal to b squared plus c squared minus 2bc cosine of the big angle. So little a squared is equal to b squared, which is 400, minus 30 squared plus 30 squared, which is 900 minus 2 times 20 times 30 times the cosine of that angle right there. Up, and they give you cosine of A, which is cosine of 60 degrees. Cosine of 60 degrees is 1/2. I know that to be true. So that's going to come out A squared is equal to, I'm going to use my calculator on this. No, I'm not going to use my calculator. I'm just going to look at the example. That's correct so far. I should come out with 700. So A is approximately 26 inches. And that's your little A. Now from here, that's equal to 26. Hope you can see that. Of course, it's in inches. Now you can use the law of sines to find angle B. Yes, angle B and angle C. Sine of A over A equals sine of B over B. And I'm not going to finish the rest of the problem out for you, but you understand how it works now. Okay? The law of sines is pretty simple. It's not that difficult to use. The next part we're going to do is in example 2. Example 2 says this: the diagonals of a parallelogram are 24.2 inches. So diagonal 1 is 24.2 centimeters. And the second diagonal of this parallelogram is 35.4 centimeters. And they intersect at an angle of 65 degrees. 65.5 degrees. Find the length of the shorter side of the parallelogram. So first thing we want to do is we want to draw it out. Here's diagonal 1. Here's diagonal 2. Since the diagonal is 24.2 inches, we also know something else, that the diagonals bisect each other on a parallelogram. So it would be 12.1 centimeters. The diagonal second one, note if you're not drawing scale, it doesn't really matter which one you use, you'll get the same information. 35 so let's do it this way. This is going to be 12.1, and 35.4 divided by 2 is 17.7, so that's going to be 17.7 degrees, centimeters. We have that angle right here. It's 65.5 degrees, and we're trying to find out the shortest length. Let's I'm just going to rewrite it for you really nice and neat here. I'm just going to highlight it too, that way you can see it better. So you have this angle that looks something like this: 17.7, 12.1, and then 60. That angle here is 65.5 degrees. And we try to find the shortest length. You have an SAS situation. I'm just going to set up the process for you, and you can finish the rest of the information. So let's call this C squared is equal to A squared plus B squared minus 2AB times cosine of angle C. C squared, that's what we're looking for. A squared is 17.7 squared plus 12.1 squared minus 2 times A, 17.7 times 12.1 times the cosine of 65.5 degrees. And just use your calculator to figure that out and take the square root of your answer, and that's what you should get. I believe the answer is approximately 16.8 centimeter. I'm going to bring my calculator out just to show you guys how to do it a little bit more efficiently. Okay. On your calculator right over here, because of the angle, I'll try to make it as best as I can. 17.7, use the square button right over here, okay, plus 12.1 squared minus 2 times 17.1 times 12.1, excuse me, I'm going to go back, it's 17.7, and times the cosine of 65.5 degrees. So there it is right there. That's 840. I took the square root of the answer. That's your answer. There's a, let me get this a little bit angled. There's your answer key right here, right in this blue. So I use the answer key. That way I don't have to retype this in. Okay, it's a little bit easier for you guys. You should know that by now. That's your second best friend. Your entry button should be your best friend. And 28.99. Ooh. Let me check this out. Probably I'm in the wrong mode. So I go into my mode. I go into degrees instead of radians. I get out because I'm in the wrong mood. I can't get my answer. So let's do the entry again. Second entry again. See, it's your best friend. Let's do the entry again. Second entry, I know that that's the answer. That should be 16.8. 16.8 centimeters. And so it's a lot easier if you use your entry button and your answer key. Okay, it's in the blue, so you have to press second. Okay. Next problem. Let's say you're given 3 sides. So we're going to cross this out. Example number 3. Let's say you're given side of angle A. Side A is 34 kilometers. B is equal to 20 kilometers. And little c is equal to 18 kilometers. I'm used to writing centimeters. I know Mr. Dr. McKee is very notorious for centimeters. Anyways, 34 kilometers, 20 kilometers, and then little c is 18 kilometers. I'm going to do part of the problems with you, and then you can finish out the rest yourself. It's not that difficult, and give you some ways to work it out. Okay? So we draw the triangle again. I don't know, maybe if I have enough time, I'll actually do the whole problem. Big A, big B, big C. Little a is 34, little b is 20, and little c is 18. I'm going to label that little c, label that little a, label that little b. In this situation, I love to use the law of cosines. Since I don't have any of the angles, I'm going to get an equation with 2 unknowns. We really don't want to work with the law of sines. As I said earlier, the law of cosines is great for side-side-side situation and the SAS situation. So let's get started. You can pick any formula you want to use, okay? I prefer c squared, but let's try a squared equals b squared plus c squared minus 2bc cosine of big A. We're trying to find out what this guy is right here. We have all of the information of the 3 sides, so we can actually try to solve it out for the cosine of A at this stage, or just plug them in as you go along. What I'm going to do is I'm going to try to solve it out for the cosine of A in this situation right now. So I got to get rid of this guy, this term, and this factor, or these factors. The way I get rid of b squared, I subtract it. The way I get rid of plus c squared, I subtract c squared. So I end up with a squared minus b squared minus c squared is equal to negative 2bc cosine of